Alright, so in this video, we'll be learning how a BCD adder works. And first of all, for introduction, a BCD adder stands for binary coded decimal, which means usually a 4-bit binary number will represent a single decimal digit, as seen in this table. So 9 will be represented by 1001, whereas 0 is represented by 0000. So this sort of a numbering system is often used in the BCD adder circuits. The BCD adder circuit looks something like this. It consists of two binary adders, which are 4 bits, and they have a correction circuit in between to add a 0 or a 6 if the sum is more than 9. This is an example of how the BCD sum works. So as seen in these tables, the input numbers and the corresponding output sums are shown in this table. Now, in order to implement the actual BCD adder schematic, we're going to use Xilinx IC design tools. And we're going to have two different approaches to this problem. We're going to construct the schematic in the first part, and we're going to generate a test bench for the schematic. And then we're going to do the actual Verilog code for the BCD adder and design a test bench for it. So as far as the schematic goes, I've already made it here, and it looks something like this. So it consists of two 4-bit adders cascaded, and there's a correction circuit which consists of a 3-input OR gate and two 2-input AND gates. The carry out is taken from this correction circuit. The output, as you can see, is a 4-bit number. Now these 4-bit adders are nothing but ripple carry adders cascaded internally in this block. So this is nothing but 4 2-bit ripple carry adders. So after connecting the schematic as shown here, we're going to go ahead and generate a test bench for this. So a test bench will look something like this. This basically is a test bench for just one case of the input. There's going to be 19 different cases which you can figure out and test the schematic out. So let's go ahead and run this test bench. Okay, so as you can see, for the input of ones for all of the input bits, we're getting the output as 1010 and a carry out. I've also done a test bench that goes through all the cases of this input, and the output should look something like this. So here, for all zeros, the output is 0. For A0 equals 1, the sum is just going to be S0 equals 1, and so on. Now we're going to look at the Verilog code for the BCD adder schematic. So the Verilog code looks something like this. It's a really short code. So all this code does is it does a basic sum of two 4-bit inputs, and with the always block you just get to add the error correction circuit by adding a 6 or a 0. when this case is met, which is S2 is greater than 9. So when the sum 2 is greater than 9, you'll add a 6 to the total sum. Otherwise, it acts like a standard addition circuit. So it's a pretty simple code. And I've also generated a test bench for this code, which looks something like this. There's a little more cases this time, and you can add more cases and see if your circuit works the same way. So let's go ahead and simulate this. Right, so the output signal is a lot more clear here because our inputs are in the form of 4-bit vectors instead of individual bits. So it's a lot easier to see the output results. I'm just going to change these to decimal so it's a lot easier to read. Alright, so let's check if our adder works. So when the input is 1 and 0, the sum is 1. And the input is 2 and 0, the sum is 2. That's working so far. So moving on, let's say the input is 9, the input 1 is 9 and input 2 is 2. And the sum is carry out of 1 and sum of 2, which means this works, right? Here again. Oh, and on the previous case, by the way, the carry in bit is also considered. That's why the sum is 12 and not 11.